This week's episodes were brought to you by the generous support of Andrew Henninger. Hey folks, Quill18 here, and welcome to another episode of our Project Porcupine series, where we are making a base building game. We are still working on improving and developing our furniture tiles to work a little bit better, and mostly to make doors work, for example. But before I do that, I want to address a couple of issues that were brought up in some comments. There is a bug in our pathfinding code that Waita has pointed out over here, and it's right, no, not in furniture, right over here. So, in our code in the pathfinding that we mostly followed from the pseudocode, our code here is mostly identical to the pseudocode, but there was one little difference. What we have done is this line here in the pseudocode for A star, the one that you find on Wikipedia anyway, does not use a priority queue in there. It just says grab the node from the open set with the lowest priority, or highest priority, the lowest priority number. Okay, grab the node from the open set with the lowest priority number and set that to current. Now, we use a priority queue implementation over here, simple priority queue, to implement that so that when we dequeue the first thing in this queue, it's automatically the thing with the lowest priority number, which is great, which is excellent. But there is one gotcha. We change, it's based on the priority in this case is the lowest F score. We're grabbing the node with the lowest F score. And we are not updating that. At the start of the run, there's only one thing on this queue. And as there's only one, when we start executing the pathfinding, the only thing in the open set is our start node, which has a priority of 0. And then what we do is we add things to this open set by exploring the neighbors from our current tile. So we look at all the neighbors from our current tile. We find out if it's actually a legal tile. We calculate its F score, and then we add that thing to the queue. So as new nodes get added in, they get added in with their F score. The thing is, it is possible to visit a node twice. It's possible depending on a complex map, which we don't have. Our map is relatively simple, so suspect we haven't really run into this issue. But depending on how our map is laid out, it is possible, let's say, imagine you could walk around here, which I guess we could if we had flooring sort of here and say here, right? And let's say I want to walk from here to over there. There's more than one way to get there, and we might sort of figure out a path. And I don't think this is going to be the case given the fact that all our tiles have a movement cost of 1 right now. I think that, you know, if our goal tile was over here, it would figure it out by going around this way. And I mean, we could confirm that. It would go around here, and that would be fine. But because, especially on a map where you have different weights of tiles, some tiles are harder work than another, the first one we find a route to might not actually be the cheapest route. We might find another way around through like a little narrow pass, for example. It turns out there's more than one way to get there. And the second way we find might actually have a lower F score because of reasons. And right now, that would not get updated in our open set over here because, again, we follow the pseudocode, which didn't use a priority queue. So we have to make sure. So this is, if the open set doesn't contain this neighbor, we add it in. But if it does contain, we need to make sure to update the F score. So in our open set, we can update the priority of a node. We have to tell it what node. In this case, it's the neighbor. And then we have to give it its new priority, which is this F score. So we have to update the F score of it. We haven't run into an issue caused by that, but later on when we end up with more complex maps, with multiple paths and more, you know, different terrain costs, that sort of thing, we might have noticed some weird pathfinding behavior, and that would have been a really tricksy bug to track down. So really good eye there, Whiteout. Thank you very much for spotting that. The other thing is less of a bug and more of a typo. Fern parameter. There we go. Fix that spelling now. I know it was driving some people crazy. Let me just check if there's any other. No, okay, no other. I think that was the only place where that was misspelled, but it was driving some people bonkers. Okay, so let's go back to adding some new content. Oh, I guess what we should do is make sure that, you know, this actually works. Pathfinding test. Build a wall over here. Well, that won't work. You can't get there, of course, but you can get over here. Oh, so if this job requeuing stuff is really annoying you, there's a few different things you could do. You can put in delay on rechecking a job. You can like make your character work sort of a dummy job to just stand around there for a while. Like if you don't find a valid job, do some sort of wander behavior for a couple of seconds, then look for another one. Again, I'm just going to leave it in here for now, but that would be a very easy thing to get around if this is driving you crazy. Don't worry about it. Okay. So, furniture, yes. last time we started working on the door, and then we had to make a bunch of changes to our serialization. Oh, one other thing I want to address. A couple of people have definitely mentioned that, hey, when you serialize, why not skip serializing empty tiles? Which you could absolutely do, because when we do create the new world, we create the world based on its width and height and set it all up with a bunch of empty tiles of that. So is there any reason you have to save and load empty tiles? And the answer is no, and it would actually be very, very, very trivial to simply not write out tiles that are empty. It's a very, very easy thing to do. Right over here, basically, we could do a check, basically just if tiles x comma y dot type not equals tile type dot empty. So we just don't write it out. That would save a little bit, and then, you know, obviously wrap it in curly braces, and then and that's it. You wouldn't even have to change your read code, because your read code simply would not do anything. For any tile that's not in the XML file, it doesn't read it in, but that's okay. The default setting in that case is perfectly okay. But we have to be sure that the only data that the tile has is empty, and that there's nothing else that we might want to write into an empty tile. And mostly it comes down to how we do the furniture. If we're doing the furniture in a different XML element like this, as opposed to nested inside of a tile, then that's fine. Because you could imagine a situation perhaps when you could have a character or some sort of object or whatever in a tile that's quote unquote empty. Like, for us, an empty tile means empty space, like outer space. But there could be something floating in that area. So as long as you don't have anything nested inside of this tag in the same file, save file, it's fine. And right now, that is the structure that we're using, so we could skip empty tiles completely. But we have to make sure that that's what we're doing. We have to be consistent in that. The other thing is, if later on, instead of actually writing out the tiles this way, if we decide to write them out as a bitmap or something like that, then we wouldn't. Then we'd change this and we'd sort of dump all tiles or some damn thing like that. That would be more if we were going for a binary save file. So as is, it doesn't really make much of a difference. I guess we'll leave it in here because some people were concerned about that. This will mean slightly less writing to the XML. This actual code here is very fast, so it's mostly a question of making the save file a little bit smaller by not bothering to make entries for empty tiles. And I guess that's fair. It'll also cause us to load things a little bit faster. In fact, that'll probably dramatically improve if I go and... I mean, we should still be able to load our data. Nothing has changed there. Oh yeah, my little test map there. Let me make a new map, open up a pathfinding test, drop maybe a door in there. And I'm going to start a wall there just so that it can save you with the character part way. And if we load this, this should be loading a fair bit faster than the old one just because it has to process fewer empty tiles. But it's not a big deal. Okay, yeah, we'll put it in there. That's fine. Okay, let's go back to talking about the furniture. So when we last left things off, I think we were talking about the situation where what is the pathfinding cost of a door? And we had already... Oh, no, we hadn't done it yet. Door pathfinding cost. Okay? And we had flagged the wall is impassable, let's get a 1, but a door we set it to 1. It has a normal pathfinding cost, which means now, all of a sudden, we should be able to walk through doors. Right? Having done that. Let me make sure we're back on board. So if I load that, try to build a wall there, we can walk through the door, which is fine. But, and that's good on the pathfinding side. We want the pathfinding side to treat a door as, yeah, we're totally happy with walking through. Oh, and we changed, actually, that's not true. We changed the, oh no, we were testing with different costs. We'd set this to like 50 and confirmed that walking through that was more expensive. But yeah, now we actually want the movement cost to be a wee bit different than this. And I guess this is the thing where I was talking about for a while about doing a subclass. Right, this is kind of a cool solution right here for that is really compatible with doing some sort of like Lua scripting or something like that for config files, right? Having our actions being sort of fed through here or whatever. But what would be really nice is when we ask something for the movement cost, is if we could sort of override this behavior. I don't know if that's quite accurate though. Basically, when the pathfinding system asks our door how much it costs to walk through this tile, we want the door to say, oh, the cost is 1. It's perfectly normal. But then we want, when a character actually tries to walk through the door, we want it to tell the character, well, we don't want it to tell the character that you can't walk through a closed door. We don't want to return a movement cost of 0 to say it's impassable, because that will cause the character to be like, oh, I'm trying to walk through a wall or something. Clearly, I've been given an invalid path because the map changed. I will cancel my pathfinding and then re-ask the pathfinding system to pathfind again. At which point, the pathfinding system will be like, no, you can totally walk through this area. The door is telling me I can walk through this. So, basically, we need some sort of context for this movement as to what's being asked. What is the movement cost of walking through a door? Well, it is 0. Okay? Or maybe we'll want to tell the pathfinding system, or sorry, it's not a 0. We want to say it's 1. It's normal cost to walk through the door. But we actually might want to tell the pathfinding system something like, it's 2. It's slightly more expensive to encourage the pathfinding system, if possible, to maybe avoid going through doors, because waiting for a door to open and close can be quite time consuming. But really, let's assume the movement cost of going through a door is indeed 1. The gotcha is you can't actually enter that tile until the door is flagged as being open. So I think the solution is we always return the true movement cost. We are not going to override movement cost here. Instead, I think we need some sort of function that our character calls. Okay, when our character walks, what does it do? So first, it checks to see if we've got a job. We don't have a job. Let's find a job. And assuming that we've got one, then we set our final destination to the jobs tile. That's fine. But then we also say, hey, do we have a job, and are we standing on the jobs tile? No? Well then, assuming we don't have a job, or assuming we have a job, or no, this is if we're there, we do the job. Otherwise, what happens over here? This is where, okay, at this point we have some sort of job and a target tile and all those things. Actually, we're not even asking about a job in this code. This is our do movement, okay? We don't currently have a tile we're going through. So you have to remember, we have 3 tile things, right? We have cur tile equals the tile I am currently in and may be in the process of leaving. Next tile equals the tile I would like to, or the tile I am currently entering. And then finally there's dest tile equals our final destination. We never walk here directly, but instead use it for the pathfinding. Okay? So what happens here is if we don't have a tile that we want to walk into, or the tile that we're trying to walk into is the tile we're currently in, i.e. we've arrived at our destination, we are going to check our pathfinding system to say, okay, well, I need a new tile. Do I have a pathfinding, or is the pathfinding empty? If it is, then we ask the pathfinding system, hey, we are here, we want to go to the dest tile, find us the path. But ultimately, what we're looking for is this step over right here, where we're grabbing the next tile from the pathfinding system. Next tile is the next thing we're about to enter. Right sort of here is where we want to say, hey, can we actually walk into that tile? And that's actually not something, we are checking right here, okay? We have a next tile, and then right here we check, hey, next tile, is your movement cost 0? Because if it is, then I'm trying to enter an unwalkable tile, most likely, a wall got built, so we just need to reset our pathfinding information, and I'll put in like a note here, fix me. Ideally, when a wall gets spawned, we should invalidate our path immediately. So that we don't waste a bunch of time walking towards a dead end. To save CPU, maybe we can only check every so often. Or maybe we should register a callback to the on tile changed event. See, these are all ways that we can find out if tiles have changed, and then we can use that information to invalidate our path. So this is what happens if tiles.movement cost is 0. But what if there's another case here? Okay, let's put in an else. Sure, why not? So the tile we're trying to enter is technically walkable, i.e. not a wall, but are we actually allowed to enter it right now? So what if on a tile we could put some sort of reserve tag? Because there's a lot of cases where we might want to not allow someone to walk into the tile right this second. What if the tile already has someone standing in it? Can two people stand in the same tile? I mean, there's no technical reason why they couldn't, but does it look kind of stupid if a bunch of people are standing on top of one another? Sure. Now, that doesn't mean we want to say that you're not allowed to walk into one of the tiles where someone is standing at all. Maybe you can't set a tile where there's someone like literally standing there like on guard, right? The example would be if you compare something like, so in Dwarf Fortress, many creatures can stand in the same tile, that's fine. But walking through a tile where a creature already is slows you down. I don't think the pathfinding system takes it into account. Maybe it does in the short term or something like that. Like, if you do build a hallway that is 2 or 3 tiles wide, dwarves in Dwarf Fortress will path around each other to avoid slowing themselves down. But I think that's more of a collision avoidance system than a pathfinding system. That's something we can look into later on. But other than that, you can walk through each other. So if it's a 1 tile wide corridor, you can walk through each other, and multiple dwarves can literally just stand in 1 tile as well. If you compare that to to RimWorld, in RimWorld, characters can pass through each other perfectly fine. You can have a 1 tile wide hallway, characters can walk through each other, and as far as I know, it does not slow down their movement. But a character's final destination is flagged internally as a reserved tile. I am looking to stand in this tile. No one else stand in this tile. You can walk through it. Walking through my tile is fine. You can walk through the tile I'm currently in, and you can walk through the tile that I am destined to be in. But you cannot, 2 people cannot have the same destiny tile. They can't both have the same dest tile, right? We have our dest tile. 2 characters cannot have the same dest tile in RimWorld. But other than that, they don't give a shit. But already we're starting to get a concept of like, there's a concept of maybe like a tile is reserved. So there's an idea about that. Now that's, I think, a different question. But, did I not just double click on tile? Hello, open. But, in addition to that, so those are tiles you can walk through, but you can't end up in. There are other tiles you can walk through, just not right now. So we need some sort of callback here. When we ask the tile what the movement cost is, because that's what it is. We don't ask furniture for their movement cost. We ask tiles for the movement cost, and a tile just happens to check its furniture for additional information. But we need a thing that says, I don't know, can I enter? Well, yeah, sure. Let's do something like that. Public bool is enterable? Bool. Come on. I mean, really, it's sort of a function. We could treat it like a property, but I mean, since we're never going to set this, let's make it a function. Public bool is enterable. So this returns true if you can enter this tile right this moment. Okay? And so normally this would be true, although I probably should return false if the tile is literally unwalkable. So if movement cost is equal to 0, then return false. Otherwise, the default will be return true. So what is the special case? Check our furniture to see if it has a special block on enterability. There's no way that's a word, but let's pretend. And so right now, currently the only thing that's going to set that is our door, right? So our door will say you can walk through me, but by default I'm not enterable. Should we have that be a property that can be toggled? We could also have, we could say that it's got a series of we can make a series of functions, series of actions that can be added to that says if something's walkable or not. That might be fine. Because we also need a function that asks something become enterable. In other words, a door. What I want to do is this. When a character is trying to enter a tile with a door, I want it to ask the tile, to tell the tile, I would like to enter you. That sounds dirty. And I want the tile to say, yes, you can enter me now. No, you can't enter me ever. Or a third option, which is, you can't enter me right now, but please wait. Soon you will be able to enter this tile. And so the difference will be is how we treat those responses. So I guess instead of is enterable, we could try something like try enter and keep a reference to a character or something like that. So instead of returning a Boolean, I'm going to return an integer. Let's do that. Or actually, you know what? Let's do an enum. That'll be perhaps even cleaner. So we'll have something like public enum enterability. Sure. Yeah. Yes, never, or soon. Those are the ways I want to return. Yes, you can enter me now. No, you can never enter me. You can enter me soon, but not right now. So, yeah, sure. Let's go with something like that. So, is enterable. Now, usually with is enterable, you expect it to return a Boolean. Like, when you start with the word is, convention is just this should return a Boolean. Let's leave is enterable as is until I can think of a better way to name it, okay? But, so, if movement cost is 0, then we return enterability.never. You can't. The default will be enterability.yes, but we'll check the furniture at this point and potentially return soon. And that's also where we'll tell the furniture, like, hey, let's start opening the door. And I think that's what's going to happen. I think there's going to be a function. I think I'm named a function, a public action. It's going to return, I guess, return the enterability. And it's going to be called enter request. Callback, enter requests, process enter request, or is enterable. Tell you what, let's just keep that going on. So it's going to have a placeholder for an action called is enterable. So if furniture, so if we have furniture and it's not null, and furniture dot is enterable is not equal to null, then we are going to return the furniture dot is enterable. And I just realized that's an action. Actions don't return anything. I'm doing this wrong. This is a parameter. We actually want this to be a func. Has no parameter and returns enterability. There we go. Furniture.isEnterable. So we're going to return the furnitures. So, I mean, we just check our movement cost, which actually, at the same time, this is actually checking the furniture's movement cost. But we assume if it's 0, we just return never. I suppose we could do it in the opposite order, and that would be fine, too. It doesn't really make a difference. Man, how many typos am I going to make? No. Okay. If our tile's not walkable because we're empty or we're something else, we return never immediately. Then we check the furniture, and we return whatever it says. If it's got a function for it, great. And we assume at this point, if we don't have a furniture or if it didn't have its own function, and clearly our movement cost is fine, then we assume that we are enterable. There. Okay, great. So with our doors, which we create over here, is we say something like our furniture prototype.door is enterable. We're going to give it some sort of function that gets called there. And so we already have a furniture actions file over here. Okay, I swear I'm double clicking. Maybe it's still compiling here and then it's not responding to my click. So let's make a public static enterability status. Come on. Enterability door is enterable. And right now it doesn't take anything. And what it's going to do, it's going to check. We're going to have a parameter. Wait, it takes furniture. Of course, it's got to take furniture. What's the... Hold on. I can't remember. I think the return is the last thing. Yeah, the return is the last thing. So this requires us to pass in furniture and returns the enterability, and so down here, no, in here, we let it know this, because it's not using a this. We could do it with a this, but this will work. Anyway, shut up. This will be fine. Right, so with our door, we have certain parameters that we play with our door. All right, we've got an openness number. So basically, if our fern parameters openness is greater or equal to 1, I mean, it should never be as high as 1, but if the openness, what is this type? It's a float. Fern parameters openness, if it's greater than or equal to 1, then we can return that, yes, you can totally walk through this. Otherwise, we will return an enterability of soon. This door, is it open? Then yes, you can walk in. If it's not open, then we tell you that you can enter it soon. But we are going to start opening the door. So what we're going to do is, and we don't have a key phrase for this yet, but there's going to be a value, a parameter here, spelled correctly, for door called, what did I call this? I was debating a name for this at some point. I don't know. Is opening. Yeah, sure. Is opening. Which is going to default to a value 0. Basically going to treat it like a Boolean. But here we're going to say, okay, if it's open, then we can return yes. Well, okay, we know at this point something is asking for the door to become open. Something wants to enter this tile. So something's made the request. So let's say, at this point, we're going to say is opening. We're going to set it to equal to 1. We're going to set it to true at this point. Someone is asking for this door to open. So then what we're going to say is this. In our door update, which will run every frame, we will say, hey, if door is opening is greater or equal to 1. I don't know, we could just do equal or whatever, or we could treat this like, this could be like digital values. And if it's got a value above this fuzzy value, then we open it. And maybe we do something like that. But for now, it's going to be fine. If is opening is greater or equal to 1, then we're going to open the door by a certain amount. Let's say, we don't have a door opening speed right now, but let's open it based on delta time times 4. So it's going to take a quarter of a second for the door to go from closed to open. And then else, it's going to close. And you could imagine that the speed at which a door opens or closes is going to be, it could be different. Door could open very fast and close slowly, or the other way around, or something like that for different effects. We're going to make sure that this value is clamped. So openness is equal to mathf.clamp. We're going to use the 0, 1 to ensure that it stays, because then we don't have to pass any parameters, just shorter. So this will make sure that the openness value stays between 0 and 1. It doesn't go above 0, it doesn't go above 1, or it doesn't go below 0. That way it'll always be within this thing. And here we'll put in a little check. So if the door is flagged to be open, then we increase its openness. But then we say, hey, if the openness is gotten greater than or bigger than 1, then the door can start closing again. I mean, maybe that'll start closing too quickly. But for now, let's do this. So if the door is supposed to be opening, we start opening it more. If it's gotten fully open, then we start closing it. If people are continue to try to enter it, then we're going to keep setting this to 1 every frame. If they keep trying to enter this doorway, the doorway is going to stay open because every frame this value is still going to be a 1. But otherwise, we're going to start closing it again. As soon as people stop asking for it to be opened, then this is going to run on the following frame, and it's going to start to shrink down until it's fully closed. Boom! So now we have a door that opens and closes, and we also have a door that responds whether it should be open, whether you can enter it now or whether you can open it and enter it later. Actually, let's slow down. I'm going to remove this times 4. It's going to take a door a full second to open and a full second to close. I like that. That way we'll be able to really tell what's happening. So in our character here, instead of asking if the movement cost is equal to 0, we're instead going to say, I mean, we could use a switch for this, but let's say we're going to ask if it's enterable. If isEnterable is equal to enterability.never, if you can never enter it, then that's when we bail. But we'll do an else if, and again, this is why you could use a switch, which would be just fine. Else if the isEnterable is equal to soon, then let's use the correct little symbols here. There we go. Okay, we can't enter the tile now, but we should be able to in the future. This is likely a door. So we don't bail on our movement/path, but we do return now and don't actually process the movement. So let's try that if we just returned at this point. So we can't enter it because it's not enterable yet, but it's enterable soon. I have no idea if we're doing this right. Let's see what happens. So if I hit play, we've got a compile error. First thing to deal with. We don't actually assign it. Right. Furniture actions dot door is enterable. There we go. We'll just feed that function in there. That way it can get called. Okay. So what's going to happen when our character tries to enter a tile, it asks to see if it's enterable. The tile isEnterable gets called. If we happen to be walking into a tile that's got furniture, then and it's got an isEnterable thing. So walls don't, but the walls, see, this movement cost asks for the tile's movement. So the walls at this point, right, if we check movement cost, and this is a tile that has a wall in it, well, what's going to happen is it's going to check to see, hey, we've got furniture, right, because it's not null. So we're going to use its movement cost and return that, and it's going to report the value. We're going to be tuning this later on, but for now. So that way, any tile that's got a wall in it will return 0 over here. Any tile that doesn't have a wall in it will return a 1, either because it has no furniture or because our doors have a movement cost of 1, and 1 times 1 is simply 1. So that's going to move on from there. Excellent. Great. But, so that's this step. So walls at this point will return a 0, so it's not enterable, and anything else will not be a 0, so it'll move to the next bit over here. Check to see if it's got furniture, and if furniture has a furniture.isEnterable code, which will be true for our doors, so that'll get run, and that value gets returned. Otherwise, we say you can walk in. Okay. So far, so good. I'm not sure if the openness and is an openability over here, because we don't actually check, when we read these, we don't actually check to see if they've been assigned. It's going to be fine for any doors that got spawned and get copied from here. We are copying these values, though, so that the default values will be copied. So even if they're not in the save, they're still going to be there. I think we're going to be fine. So let me try to tell it to build a wall. First, let's build a wall over here. All right, everything is good. Now I'm going to click to build a wall here. Now, the pathfinding system is just going to tell our character that you can walk through here just fine. The question is, when it gets to here, it should check to see if this tile is enterable. It should return soon, which means our character will just wait. And every frame it'll keep asking. And over the course of 1 second, this door will become open. And then, I mean, not visually, but it will be switched to open, at which point our character will walk through. Okay, we can walk here. The character should pause. It didn't pause! All right, we need better debugging information, clearly. Why didn't it pause? That's a great question. Why didn't it pause? Because it should be here, returning enterability soon, and bail. Here's a question. Are these things running? Well, this should, I mean, actually, it doesn't matter if this bit is running or not, unless it's like opening instantly, which I guess is possible. Let's have it return the status of openness every frame. Maybe I'm a little off with one of these things and it's just opening it too fast. I don't think that's true. And let's put a debug.log. I mean, I could just go into actual debug mode at this point, and I may have to. But let's see what a couple of just debug.log commands do for us. Load. Build wall. Door action is running, and it's got a an openness of 0. Okay, it's got an openness of 0 all the way through here. So this is not running. which is, no, this is running. This is not running. So let's remove that debug and confirm door is enterable is not being called. Pathfinding test. Oh, not pathfinding test. Actually, let's start with a fresh one. Pathfinding test, build a door over here, build a wall up here, and then down here. Okay. It is not calling door is enterable. Which doesn't seem... Because our copy constructor is not copying the door. So we're setting the prototype's version of is enterable, but we're not copying that from into the actual instance. There we go. So let's do that. And again, this should work with our save file perfectly fine. So yeah, our instance wasn't getting that because it wasn't in our copy corrector. So if I hit this, yes! Yes! And now at this point, the door should be closed again. So it does that. But if we're fast enough going back and forth, the door shouldn't be all the way closed. Because it only takes a second. I guess it does take a tick to actually build the wall. So in that time, the door is closing quite a bit. But if I did something like that, shouldn't have to wait very long the other way. And you can see he didn't wait very long. The door hadn't closed all the way yet. But now we have that little behavior, which is freaking awesome. And this whole sort of code with is a tile enterable will factor into all kinds of stuff with whether you can walk through a tile where another character is, and all kinds of other objects might decide whether you can enter a tile or not. You know, they could have like force fields that take a while to go up and down, or slow you down, or have some sort of other weird behavior. And yeah, the door code can be expanded a lot. Now, one of the things here is, what if a door is locked? Well, if a door is locked, then what it should actually do is set its walkability to 0. Right? I think that would be, if you, in the case of a locked door, you should set the walkability to 0, because the pathfinding system should not allow you to attempt to walk through a door that is locked. Or later on, if we have faction mechanics on doorways, right? So our character is allowed to walk through this door, but enemies are not allowed to walk through this door. Then the pathfinding system should return, you know, yes for some people, no for others, so that walkability, or the movement cost number should change from one to the other. Or rather than say enemies aren't allowed to walk through this door, what we could do is set the pathfinding cost of walking through a door very high. So enemies normally will not walk through doors. They'll find another way around. But if there's no other way around, they will attempt to walk through a door, but rather than be able to open it, what they might do is start to smash it instead, right? If they walk up to a door and they want to enter it, but because of faction limitations, they're not actually able to just open the door because it is sort of locked to them because they don't have a password. Instead, they will start attacking the doorway. So by doing that, by returning different movement costs, you can encourage enemies to just avoid doors if there's another way around places. But if they need to go through a door, then they can, but then they'll have to start smashing it. But I'm really excited about this. This should also work fine with our save. Did we check that? Yeah, because I think I was playing that one with the load. That works fine. And then without a load, just try to build a new one. Build door, go here, build another one up here, wall down here, then one up there. There you go, and it works great there too. Really nice. And again, by writing the code this way, we get really, really, really well set up for what if this code, what if this logic here was just implemented in Lua instead, and then people could mod it and do things. And actually, I've been doing some research on this. It's really, really easy actually for us to incorporate a Lua interpreter into our code. Or there's actually a few different types of interpretation things. But Lua, for some reason, is really popular as a game scripting language. I don't know why Lua specifically. I mean, there's a lot of really good scripting languages out there, and a lot of them have certain things. Like, why not Ruby or this or that? Maybe just, you know, maybe a Lua interpreter was one of the first things that was conveniently available in like, I don't know, C++, so a couple of games started using it, and then it just sort of became a habit from then on. But that's what I'm thinking, and there's definitely actually quite a few little Lua interpreters, including some good free open source ones that we can use. And I would love to rewrite this as part of whatever file. When we read in our furniture prototypes, it's going to come in from some sort of file, and the code will be in the file, and that will define our door opening and closing behavior. Oh, it's just going to be gorgeous. Really excited to do that. But that will have to wait until the future. Thank you very much for watching, folks. Next time, most likely what we'll have to tackle is the feature of how do we get a door to look correctly over here without writing a whole bunch of crummy, degenerate code. I mean, the door works fine here. It just has the wrong graphic. Oh, and then we have to animate the damn thing. Whew. It's going to be fun. See you next time, folks. Bye-bye. Thank you to everyone who pledged to support this in February and is making these videos happen through March and early April. And of course, these mic check supporters. We've got Wes Eldenboving again, Craig Mortel, Nail Vikstrom, Neil Blakely Milner, Speedy Savant, Valent Cake Fiend, Aaron Toyson, Marius Field Vold, Ole Peter Talgo, probably Ole, Julian Ogier, Lafone, Stephen Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and Andrew Henninger. And everyone who just watches and shares and favorites and comments and subscribes, thank you so much for just continuing to make these videos a thing that we can do. I think it's pretty awesome, and I hope you do too. See you next time, folks.